All right, so another construction that we're going to work on is constructing an isosceles. No, don't erase it. An isosceles triangle. So I'm actually going to build it off of our previous construction, which was a perpendicular bisector. If you need to remember that, I'm just going to go over it really quick. You're going to use your compass tool to grab two circles and center them at A and B, using AB as your radius. Then if you notice, this is the perpendicular bisector because I'm connecting this point and this point. So therefore it becomes a perpendicular bisector. Notice this is a right angle here, and this section is congruent to this section. The last construction it says for us to do for right now says that we need to construct an isosceles triangle. So remind me again, what's an isosceles triangle? What's an isosceles triangle? Oh, I didn't see that question. I'll show you. Yes, how many sides are congruent in an isosceles triangle? Very good. Two congruent sides. So if you remember from our previous lesson, we learned that whenever this is congruent to this, any point on this perpendicular bisector is going to be equidistant to the endpoints, right? So what all I need to do is pick a point. You get to pick whatever point you want. You get to pick whatever point you want. So I am going to pick a point like this. So say you say this point here, Miss Johnson, and I say yes, that point there. So yours doesn't have to be exactly the same. In fact, I'm going to move it up and down. So then I'm going to grab my segment, see my segment section right here, and I'm going to connect A to the point on the perpendicular bisector, and I'm going to connect that to here. So we learned in the last lesson that when we have a point that's on the perpendicular bisector, it is equidistant. Equidistant meaning this is congruent to this, to the endpoints of the segment. So what I'm going to do is I am going to select this, and this is the cool thing, right? So does everybody see how, let me select this guy and label him as, I'm going to label him as D because last time we labeled him as C, so I don't want you to get confused. Okay. So what I want to do is anything that has a little bubble, see how it has like a little donut around it? I could pick it up and move it. So look at AD and BD as I move this up and down, even outside of my equilateral triangle that was right here, right? Is this remaining isosceles? Is this triangle remaining isosceles? Yes. Does AD look congruent to BD? Here, I'll label them red so they stand out a little bit more. Do those two red segments look congruent? Look, here, everyone says yes. Here, yes. Here, 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 here. Equilateral, yes. Here, here. I can go all the way up outside of my Desmos window. It'll still work, right? So no matter what I choose, I'm always going to have an isosceles triangle. So remember that theorem that you learned. It said any point, I think it was if a point is on the perpendicular bisector of a segment, it is equidistant to the endpoints, meaning congruent. Or if you want to say it like this, any point on a perpendicular bisector creates an isosceles triangle with that segment, right? However you want to remember it. That's basically what they're saying. No matter how I put this, it's going to remain congruent. Everybody okay with that? Very good. And that is how you construct an isosceles triangle.